Okay, guys, we're going to be looking at finding the square root of a complex number. So here's our first question. Is find the square root of 5 plus 2i. All right, first thing I'm going to do is I'm going to say let z equal to square root of 5 plus 12i. Where z is equal to x plus iy, right? And remember, x and y are elements of the real number system. Okay, so x and y are both real. Now, that's how we start the question off. And now I'm going to square both sides. So z squared is equal to 5 plus 12i. And z is x plus iy, so I'm now going to do a substitution, x plus iy all squared equals 5 plus 12i. Then I'm going to expand the brackets, so x squared, and I'm going to put plus I squared y squared plus I to xy equals 5 plus 12i. Okay, now let's tidy this up a little bit. We're going to have x squared minus y squared now, because I squared is -1, plus I to xy is equal to, actually what I might do, just to make it match perfectly, I'll get rid of that I there, get rid of all of that, and I'll just write this as 2x, y, I. Okay, now next step. Actually, I've got to write this down as well. Next step is to look at the real and imaginary parts and equate them, okay? So, on the left-hand side, this is the real part, and that matches up with this real part. And then on the left-hand side, we have the imaginary part here, that matches up with 12 here, the imaginary part. So, our next step is to equate real and the imaginary parts. Okay, so first one, we're going to have x squared minus y squared is equal to 5. All right, I'm going to call that equation 1. And the next equation we have is 2xy. So now I'm equating the imaginary part. 2xy is equal to 12. Okay, now that obviously can be simplified to x, y is equal to 6. I'm going to call that equation 2. All right, now there are two methods we can do to continue. First method is called the method of inspection. So let's write this down as method 1. Right, this is the inspection method. So with the inspection method, I'm just going to look at these numbers here. Now, basically what have I got? I've got xy is equal to 6, so two numbers which multiply to give 6, and I've got the difference of those two squares of those numbers equal to 5. So straight away I'm going to think I'm going to try x equals 3 and y equals 2. Okay, now let's see if it works. 3 times 2 is equal to 6, and then 3 squared minus 2 squared equals 9 minus 4, which equals 5. So you can see that 5 there matches that 5 there, so that works. And the 6 there matches the 6 over here. Okay, so those two numbers work. I can think of another two numbers though. What about x equals minus 3 and y equals minus 2? Okay, now check that it works. Obviously, negative 3 times negative 2 is positive 6. And negative 3, subbing us into the first equation, negative 3 squared minus negative 2 squared equals 9 minus 4, which equals 5. So both of those work. All right. Now, if you didn't spot 3 and 2, you could have tried 6 and 1. 6 and 1 works for the second equation, but it doesn't work for the first one because you'll have 6 squared minus 1 squared is 36 minus 1, which is 35, and that's not 5. Okay, now we've got our two values, so we can now write down the answers. Okay, so Z equals 3 plus 2i, that's one solution. Over here, Z equals minus 3 minus 2i, because remember Z was equal to x plus iy. Okay, now we could also write them more efficiently. So I could write down this with a negative common factor. Okay, which means I could write my solution in one expression. I could write this as plus or minus brackets 3 plus 2i. You can leave it separately like this, that's fine, or you could write it like this. Now, that means we can write a conclusion, right? Now, conclusion. Right, so every non-zero complex number has two square roots that sum to 0. So, how does that work? Well, let's have a look. Put down a little example here. What we just did. If I take those two answers that we found, I add them together. Right, what do I get? I get 3 minus 3 plus 2i minus 2i, which equals 0. Okay. All right, so that's method 1. That's the method by inspection. Let's have a look at method 2, which is involving simultaneous equations. Now, method 2 is important because with method 2, you may not be able to do it by inspection, so you need a backup method with using algebra. Let me just add a page here. Okay, so edit, page, insert page, will do. All right, so method 2. Let's have a look at method 2. Actually, I'm just going to swap those pages around. Okay, so make this page 1. So edit, page, move page up. There we go. All right, So let's have a look at method 2 then. So method 2, right, is the simultaneous equations method. So let's just write that down. Method 2, simultaneous equations. Okay, so now recall that for the two equations, we had the following. Let's write them down again. We had x squared minus y squared equals 5. We also had x, y is equal to 6. So call that equation 1, call that equation 2. All right, now, from equation 2, what can we write down? From equation 2, y is equal to 6 on x, right? And what we're going to do then is we're going to sub into equation 1. Okay, so what does that give us? Right, that'll give us x squared minus 6 on x all squared equal to 5. That's going to give me x squared minus 36 on x squared is equal to 5. Okay, now from this point on, I want to get rid of the denominator. So I can solve the equation. So I'm just going to multiply both sides of the equation by the denominator of 36 on x squared. So times both sides by x squared. That's going to give me next x to the 4. I'll get x to the 4 there. Minus 36 equals 5x squared. I'll put everything on one side. X to the 4 minus 5x squared minus 36 is equal to 0. Now, factor this. Think of this as a equation which is reducible to a quadratic. So x squared there, x squared there. You would have done these sorts of equations in year 10. 9 there, 4 there. Minus there, plus there. Okay, now from that point on, I'm going to write down two possibilities. One of them will not be correct. See if you can spot which one. So I'm going to write down x squared plus 4 equals 0 and x squared minus 9 equals 0. So then I get x squared equals negative 4. And then taking the square root of both sides, we get x equals plus or minus 2y. Over here, I get x squared equals 9. And then x equals plus or minus 3. Now, remember earlier in the working, we said that x and y were elements of the real numbers, okay? Which means we can't have imaginary solutions. So this whole bit here is not possible, okay? So in future, you would not have to write that down for other questions. You would just stick to the part of the equation which is going to give you a real solution, okay? So now we've got two values of x. So let's take the first one, x equals 3. We're going to sub that into one of the equations we had earlier, which was 6 on x. So sub into y equals 6 on x. That's going to give you y equals 6 on 3, which equals 2. Right, so therefore, z is equal to 3 plus 2y. That's one of your solutions. And the other solution, of course, is you've got x equals minus 3. You'll sub into y equals 6 on x. That's going to give you y equals 6 on negative 3, which is negative 2. Okay, so therefore, z is equal to negative 3 minus 2y is the other solution. Okay, so make sure those notes are copied down, and the exercise I want you to do is 102. There we go.